Welcome to this session. In this session, we will try to understand IP address. IP address is the concept which we saw in the network layer. Okay? Network layer. It is the concept which comes in the network layer in the network models, right? So, let us start with very basic. You are here. You are here. You are accessing a website. You have this system and you are accessing some website here. Okay, you are accessing some websites. This is how the scenario looks like. So what happens first? As soon as you on the system, right, your OS will send a request to your router. It will send a request. Now this request we have seen is a part of application layer, and this request is of what form? It's a DHCP request. Okay, this we have seen. So DHCP is the protocol which comes under the application layer, right? So OS make a request to the router. Now DHCP request is made. Now where is the DHCP server? So DHCP server lies inside the router. So router act as a DHCP server. Okay. So the router will provide the IP address. So this request is for give me the IP address. This request is simply like this. Can you give me the IP address which is available? And the router replies with the IP address. So router will say, okay, take for example 192.168.1.10. Take this IP address, and this IP address will be given to your system. Now, if you do IP config on your system, you will see the IP address, IPv4 address as 192.168.1.10. Okay. So as soon as a request received, the OS send acknowledge, and that IP is for your session. So till the point you keep your system on, right? This will be the IP assigned to your system. So this is how you get IP address. Okay, get IP address. I hope everybody is clear how we get IP address internally. Okay, now let us try to understand what is IP address. What is IP address, that we will try to understand now. Okay, what is IP address? So we have seen, right? We got the IP address as 192.168.1.10. 1.10 we got. So this is the IP address which we got. Now what is this IP address? What is this IP address which we are talking about? So IP address is it's a logical address that identifies uniquely a device over the network and tells the network where that device is located. Okay, so it's a logical address over the network. So now network can looks like this. Okay, this is your router. So this is your router, and this might be your device. This is your device. So the IP address tells that your device is located here in this network. So in simple term, IP address is a home address of a device on the internet. It's a home address. Now we will understand it more, this concept, right? How it identifies uniquely over the internet. But as of now, you just understand that it is an address of your system to identify your system within that network. This is important. Within your network only. Within your network. This is important. Okay. Now, without IP address, if you don't have IP address, right, then what all are the things can happens. So without IP address, your internet cannot route the data. You cannot communicate with others, right? Because you cannot route the data because you don't know where your device is located. If since your device we don't know where it is located, your router cannot send the data to it, right? And your entire communication collapse. You cannot communicate with each other. So that's how not having IP address can cause the problem. Okay, so IP address is must for any device. Now, why IP address is needed? Let's try to understand it more. Right? Why IP address is needed? Now, why IP address needed? Why it is needed? So, imagine a courier system. This can be very easily understood by relating it to our postal system. Okay. So, if you want to deliver a package, okay, or parcel you want to deliver. So, what happens? To deliver a parcel, what you need? You need country, you need state, you need city, you need street, you need house number, right? Similarly, in the network, means in the internet, if you want to deliver to somebody over the internet, you need network part and you need a host part. Now, in this postal system, right? Postal system, all this is a part of your network part. Okay, and this is your host where the exact host is lies, right? So this is your host part. So every IP address, whatever we have seen, right? 192.168.1.10. This is the IP address which we have seen, right? This is your network part. Okay, and this is your host part. Okay, so every IP address will help to identify the device in a particular network. Okay, now internet is composed of many networks, right? Now this is one of the IP address. Okay, now this network, whatever network is having, this network itself can lie within another network, right? So that will have a different network address. So it's a chain, right? That we will understand soon. But understand that every IP address will have a network component and will have a host component in it. So now let us try to understand what are the types of IP addresses. Okay. So what are the different types of IP addresses which we are having today? So we have seen, right? So DHCP request. As soon as the OS on the system make a DHCP request, we saw that the router will give us the IPv4 address, right? But at the same time, it will also give you IPv6 address because these are the two types of addresses which are present. So we have a IPv4 address and we have a IPv6 address also. Okay, two types of addresses. Okay. What is the format of this address? So IPv4 will be looks like this. Okay, so it's a four numbers. Okay, we have seen, right, one sample IP address as 192.168.1.10. So 32-bit address because every number is a octet, right? It's a 32-bit address, right? So this is in the human readable format. But for machine level, it will be like each number will be converted in the form of binary. So in binary, it will look something like this. Okay. So all these numbers are converted to binary. Okay. So 192 will be represented like this, then 168 will be like this, 1 this way and 10 this way. So this is how the number will be converted into binary. So each number, right, in this binary will have a weight. So you yourself can compute it, right? So you can start with, it will have a 8 bit, right? So 8 bit means it will start with 2 raised to 0. Okay. Then 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6 and 2 raised to 7. Okay. So this will start, if you compute, right, it will become to 128, 64, 32, 16, 8, right? This is 4, this is, and this is 1. So this is the weight for each bit, right? So if you sum it up, right, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, it comes to 255. So each number in our IP address can go from 0 to 255. Okay. So understand this, right? So you can also see 255.255.255.255 possible. You can see this kind of address also. Okay. So this is about IP address of IPv4 address, right? Now let us try to understand the IPv6 address in detail. Okay, so we have seen IPv4. Let us try to understand IPv6. So IPv6 address is a 128-bit address. It is a format of X, 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 X. It will have a 8 numbers, 8 not numbers, 8 text. Okay. So sample IPv6 address will look like this. So this is your sample IPv6 address. So IPv4, we have seen it's a form of octet, right? So each number will be represented in the octet of binary 0 and 1, right? Here in IPv6, each number will be of 16 bit, directly double from 8 to 16 bit, and entire IPv6 address will be of total 128 bit address. Okay, simple calculation, 16 bit into 8, 128 bit address. Okay, now how many combinations of IPv6 addresses available? So how many number of IP addresses available in IPv6? Can you just imagine? It's 2 raised to power 128. So it will become 340 undecillion. I myself doesn't know how to represent this undecillion address, but it's a very huge, billion, trillion, above that it will go. But in IPv4, right, we have seen how much addresses available, 2 raised to power 32 equal to 4.3 billion, around 4.3 billion addresses available in IPv4, but in IPv6 total 340 undecillion addresses are available. Now just imagine that the world population, right, is around 8 to 9 billion. Okay, world population is 8 to 9 billion. Now consider everybody is having a device. Now obviously if you have only 4.3 billion addresses available and you have 8 to 9 billion devices in the world, right? So it is insufficient for IPv4 address to give each device a address, right? It's not possible realistically. That's why they have come up with IPv6 addressing scheme. So every device, if you see, it will have IPv4 address also and IPv6 address also. So with 2 raised to 128, 340 undecillion, it is very easily possible that every device we can have a unique IPv6 address. So that is very much possible. So next question, next curiosity might comes, right? Then how IPv4 is handling this? Because there are only 4.3 billion addresses, but we have devices around 8.8 to 9 billion. How this is handled? Then this is handled with the help of subnetting concept. Okay, it is helped with the help of subnetting concept, which we will see. Now let us look at the internal structure of IP. So we have said that there is a network part and there is a host part. Correct? Network part and there is a host part. Now we have a IP address 192.168.1.10/24. Okay. Now what is the network part here? Network part is this one and your host part is this one. This is host, this is network. Now why I am saying this is a network? Because it is this 24. So 24 is suggests that the first 24 bits of this IP address are reserved for the network, are fixed for the network, right? So we have seen every number is a form of 8 bit, right? So this is 8 bit, this is 8 bit, this is 8 bit, and this is also 8 bit. So first 24 means these three will be fixed, and those suggest us the network, right? So network is 192.168.1. This is the network part. Now how the system identifies what is my network? There should be some logic, right? I also simply told you that this is the network part and this is the host part. But how? So it is because of subnet mask. This is another concept which we will cover. Subnet mask. Okay. So it actually tells how many bits belongs to network versus host. Okay. This will help us to figure it out that. So subnet mask will looks like this. 0. CIDR. In CIDR notation, it will be simply denoted as /24. /24 means all the 24 bits are 11111. So one octet of 111 is 255, right? So this CIDR, right, it's a kind of a notation. Okay, so its long form is classless inter-domain routing. Okay, there is a classful and classless inter-domain routing, right? So we don't need to understand it much, but understand that in CIDR notation, the subnet mask will be defined simply like this. If your first 16 bits are constant, then it can be +16. If your first 8 bit are constant, then it will be /8. If your first 31 bits are constant, then it can be first 31. If your first 28 bit can be constant, it will be 28. So this way. So in CIDR notations, right, first 8 bit can be constant, right? First 16 bit can be constant. First 24 bit can be constant and first 32 bits can be constant, right? So first 8 bit, if those are constant, right, means it's a very huge network. Okay. First 16 bits are constant means it's a medium network. First 24 bits constant means it's a small network. Usually we will fall here. And first 32 bit constant means it's a single device available. You can figure it out, the single device. That all the bits are constant. Like in my case, my IP address is 192.168.10.1, right? If I tell all 32 are constant, then this is my IP address of my system. Nothing will change. This is fixed. Now, one more concept here is private versus public IP addresses. So, private IP addresses are used inside a local network. Okay, for example, home and office. You will see this. So, private IP addresses will usually have the range of 10.0.0 to 10.255.255 dot 255. So it can also start with 172.16.0.0 to 172.31.255.255. Okay. You will also see 192.168.0.0 to 192.168.255.255. So these are usually a home and office network. So I am currently belongs to here. Okay. So these are the standard range. Okay. You can create a explicit range, but these are the standard range which are defined for your home and office networks. Okay. If your address belongs to this, right? First understand that if your IP address is a private, and obviously it will be private because you will fall into some home network or office network, right? If your IP address comes into this, right, then actually you are not routable over the internet. You cannot send traffic to the internet directly. Okay, if you tell that, okay, I will send directly from this IP address to internet, that is not possible because these IP addresses needs a public IP address help to send the data packets to the internet. Okay, so private IP need the help of public IP address to send the data to the internet or access the internet. Okay, so these are what we were saying. These are not routable over internet. It cannot be routable over internet, and it can be reused by anyone. For example, now this is the range which is used in Infosys, for example, in their work office. Same range you can find in TCS also. Same range you can find in Accenture also. So one of the device might have the same address. Means one device which is present in Infosys, one device which is present in TCS, one device which is present in Accenture can have the same IP address because their network has the same IP range, right? So whatever we were telling that IP address is a globally unique, right? It is globally unique in indirect way, but if you see directly, right, your IP address, whatever is given, private IP is not globally unique. Multiple devices can have the same IP address, right? It's a public IP which is globally unique. And these private IPs used behind Wi-Fi routers. Wi-Fi routers only use this kind of private IPs. Okay. Now coming to public IP, it's a very important concept of public IP. So public IP will take different color. So public IP is given by your ISP. Okay, it's a globally unique, which I was telling, right? It's a globally unique and it's visible over internet. Internet it can route. Okay, now you will say, okay, then how I am accessing the internet, right? So whatever network range, for example, you are falling into this network, right? Now this network uses the IP address which is public to access to the internet. So who gives that? That is given by your router. So what happens is as soon as you access a internet, right? You want to access a internet and which is you are accessing a website which is actually present over somewhere else over the network, right? Then you will be accessing with your private IP, right? You will have a private IP. So what happens is this private IP will be converted into public IP by whom? By your router. Your router is intelligent to convert it. Okay. It will convert it to public IP. It will access the internet. It will get the information. Then again convert it to private IP and send to the particular device because there might be a multiple devices right here in the same network. You can see this router will have 100 of device inside. Correct. It will have 100 of device inside in the network. All are having their private IPs belongs to this range. Right. For example, this is the Infosys network. Okay. So all these are my private IPs and devices present in the network, and this is my router. So as soon as anybody access internet, right, it goes to this router will have a public IP address. Okay, it can have a multiple public IP address, but those are very few. For example, you have a 200 devices, it can have only 2 or 4 public IP addresses. So as soon as you access the internet, the router will convert it to public IP address. It will get the information and send it back to you. That is called as network address translation, NAT. NAT is the process which router does by converting private IP to public IP address. Okay. So this is how you get a public IP address, and indirectly your device is unique. And this is the reason why 8.9 billion devices are capable of accessing internet with the help of 4.3 billion IPv4 addresses. Correct? Because here you can see, right, 200 devices are a part of a network which is sharing only couple of public IPv4 addresses. Only 2 public IPs it will have, but 200 devices are accessing it, right? So as soon as the request comes, the public IPv4 address will be given and the internet will be accessed with the help of it, right? So this is the reason for this magic, that we are still able to access internet with the help of less pool of IPv4 addresses. Now another concept which is important here is the concept of static and dynamic IPs. So name itself has a significant meaning in it. Static means never change. Never change. So which are the IP addresses which will never change? These are the IP addresses of servers which will never change, right? And anybody can access it remotely. Dynamic IP addresses are assigned via DHCP. Okay, it changes periodically and used by home users like us. So we have seen, right? As soon as we on the system, DHCP request will be fired to the router and we will get the IP. Now, every time you restart your system, you will get a different IP. This is because you use a dynamic IP address. Even in the cloud, if you have a EC2 instance or any virtual machine, right, as soon as you keep on restarting, right, it will get a new IP address every time. But there is a provision to get the static IP address that is a constant and will stay constant forever, right? That is used by servers. But for getting a constant IP address, right, it will incur a cost. That's why some of the website, right, Amazon, they have a static IP address, right? They have a couple of static IP addresses. That's why whoever types amazon.com, right, it will goes to the Amazon server. Why? Because they have a fixed IP address. Now last concept which we will see here. Now we are interested to know who gives this IP address to us, right? Who gave IP address? We have seen a lot of logic in the IP address. Somebody should be there to manage this, right? So there are some fixed number of IP addresses and those are managed by IANA, which is a global pool of IP address, which manages the global pool of IP address. Okay, it's an Internet Assigned Network Authority. It's the global entity responsible for coordinating unique identifiers that keep internet running. Okay. Then there comes RIRs. RIRs are regional internet registries. Okay. For example, Asia Pacific, North America, Europe, Middle East, Central Asia, they have their own regional IP addresses, right? And below that will come ISPs. ISPs are the actual internet service provider. They are the ones who actually run the fiber cables, run the fiber optics, run the wireless devices, all this, and they will help you to get the access to internet, right? And then you will have organization, right? If you are home user, then you will have a Wi-Fi, right? They will have a Wi-Fi here. But if you are a part of organization, then the organization will have IP address, and inside that you will be there, correct? If there is a home network, then inside that you will be there. The ISP will give you one IP. So that's how your IP addresses will be given and governed. So this is all I wanted to cover in this session. So if you like this video, do share, subscribe, and tell your friend about my channel. Thank you.